Okay, we are looking at the study guide for molarity and the solubility unit. Of course, up on Schoology are all of the work we've done, all the problems we've done, the answers for all the POGILs and labs and all the pieces there. That is your storage clearance house for anything you might possibly need chemistry-wise. So briefly, we're going to roll through this. I don't really have oodles to show you or talk to you about here, but I just want to spend some time going through. The molarity POGIL is where we learned about those different vocabulary words: solvent, solute, diluted, concentrated, saturation, etc. We learned how to calculate molarity. We learned that molarity is moles of solute over liters of what? Solution, not solvent, right? Liters of solution. And you did some problems in that POGIL where you were calculating the molarity from grams of solute. If we've got the grams, can you change that into molarity? You did it also with moles, but grams is a little bit more difficult because you have to use molar mass. They also talked to you about how to prepare a solution to ensure the correct molarity. So that was question number 21 on the POGIL, right? Where basically she's trying to get 1 liter of a, let's say, a 0.5 molar solution. You can't add 1 liter of water plus however many grams of solute you need, right? You dissolve the solute and then fill it up to 1 liter of total solution, right? It's going to be less than 1 liter of water because that solute has mass. It has volume. So that's also on page 44. They talk about that in detail. We had some problems with that as well. We did a phase change lab, where we were looking at the kinetic molecular theory, basically that all molecules are moving at all times, right? And that therefore lends to different pieces for solids and liquids and gases, how they're moving, right? Gases will just take up the space of whatever container they're in. Liquids the same, but they're a little more contained. And solids, they will hold their shape, right? The molecules are still moving, but they're just kind of vibrating in place there. We talked about cooling and heating curves, right? We actually made both a cooling and a heating curve for our, I can't remember what it was we dealt with, our compound. Laitic acid, or I can't remember. Sorry, my brain is very, very muddled today. We actually created our heating and our cooling curve. I won't ask you to create them, but I will ask you to interpret them, right? And we also talked about how solubility affected those same curves, right? So as I heated some solutions up, things were able to dissolve better. As I cooled some solutions down, things dissolved better. Remember we did that demonstration here together with those two different solutions that hot and cold affected differently. So that's about those heating curves. We talked about the flat points, the melting and freezing points. And what's happening? Would you remind me? What's happening at those times? Because we're adding energy for a heating curve. We're adding energy, but the temperature is not changing. So what's going on there? Can you remind me? Do you remember? It's changing states. Okay, but how does that use energy? Absolutely. It's actually breaking the bonds between those atoms to allow them to go into that new state of matter, whether, again, it's from a solid to a liquid or from a liquid to a gas. And that takes energy. All right. We talked about the factors that affect solubility. You did a good lab about that, where you decided how you were going to test how crystal size and the stirring rate and the temperature of the solvent, how those three things affected how things dissolve. And so I would want you to be able to give evidence from your lab results about how each factor affected solubility. Talking about, hey, when I did X and Y and Z, here's what happened. Some good solid results behind that. And then they talked there about the surface model, that basically the more surface area you have, the easier it is for things to dissolve, right? So that's why the powder dissolved so much faster than the big, huge crystal. That's why the stirring that's going to mix up and get different surface area interacting, why that helps so much more. And why temperature helps, because it's moving the molecules, right? Things are moving faster. Are you with me? The faster it will dissolve. Yes, ma'am. Again, think of the difference between your powder that you ground up and that big crystals. It took much, much longer for the big crystals. And then we spent some time on a couple different molarity problems. 16 through 19. This must be 20 to 23. The whole problems, all the problems I want you to have. And then 24 to 26 that we did today. So the problems kind of went into three different categories, where you were calculating molarity when they gave you either moles or grams and liters, right? So just very straightforward. If they were asking you to find the grams, if they gave you both molarity and liters of solution. And then the last set of problems was our dilution problems, where we were taking and actually diluting some solutions. A molarity and a volume of one solution and diluting it to make a new solution. And of course, that's M1V1 equals M2V2. That's it. This is what we've spent our time doing since the last ISS2. I don't think you should have too much trouble, and with a little bit of luck, you might even get an A. Any questions there? I couldn't resist. Okay.